Right, to answer this question, the first thing I've done is I've written down what is provided in the question. The sinusoidal waveform of the input voltage is given as 163 sine 377 t plus 30 degrees voltage, right? And in this circuit, there are four components: R1 15 ohm, R2 37 ohm, the inductor 8 ohm, the capacitor 16 ohm, right? So when we are asked to calculate the total impedance, since this is in series, it's very straightforward. I write out the formula. Total impedance is given as the impedance of R1 plus the impedance of R2 plus the impedance of L and plus the impedance of C. Now, then I'll just put in the phasor version. Now, phasor version in this case, R1 is 15 ohms. Since they are to be added up, it is easier for me to straight away write out the rectangular format rather than the phasor, right? So resistor is 15 ohms real plus 37 ohm real plus now impedance, the impedance for the inductor, right? Inductor is positive, so I have a positive J 8 ohm and minus J 16 ohm. Right, remember capacitors is opposite direction of in terms of phase shift, it's opposite from inductor. So in terms of rectangular format is 15 and 37, I can add them up, so that will be 52 ohms. Now this minus 8 plus, plus 8 minus 16, that will be minus J 8 ohm, right? In phasor format. Now the question wants me to convert this to the polar format, right? So using your calculator, you should be able to get 52.66 at an angle of minus 8.75 degree ohms. That's the impedance in polar form. Next, I want to calculate the supply current, right? Now, supply current using Ohm's law would be in sinusoidal version would be IT is Vt divided by the impedance Z. Right, but it's easier to do it in phasor version, so let's calculate the phasor version first. I is V over Z. Now V is 163, the peak voltage, divided by root 2, right? The angle of plus 30 degrees, divided by the impedance, which is calculated previously, 52.66 at an angle of minus 8.75 degree. Oops. That gives me 2.2 at an angle of 30 minus, so it becomes 30 plus, so it's 38.75 degree ampere. Right, so this is one part of the required answer. Now I want to change this back to my sinusoidal expression. So what do? 2.2, to get back to the peak value is 2.2 times root 2 sine omega, still the same, okay, because in any circuit omega remain the same. Now this time the angle is plus 38.7 degrees ampere. So that is the sinusoidal waveform. Okay, so I should multiply this. 2.2 times square root 2 becomes 3.1 sine 377t plus 38.7 degrees. Okay. Alright, so here's my answer for part 1 and part 2 of this question. Now we next move on to part 3 and part 4. Part 3 and part 4. Part 3 requires me to calculate the power factor. Now power factor is given as the cosine of the phase difference between the voltage and the current. That's the same as the phase angle given by the impedance. Right? So that's cosine minus 8.75 or just 8.75. Still having the same value. So that will be equals to 0.988. Now, is it leading or lagging? How do we determine? The same thing. This is the horizontal line. The voltage is at 30 degrees leading. So that's 30 degrees like that. So that's the voltage. But my current is 38.7, which is even higher, faster. Okay, so the difference here is 8.75. 0.75. So current is ahead, right? Current, because I'm going this way. So current is ahead of the voltage. So current is actually leading. Okay, that's the answer for the power factor. And finally, we want to calculate the voltage across the resistors and so on. Now, voltage across resistor is given by the current multiplied by the impedance. In this case, current, remember earlier on we have calculated it, 2.2 at an angle of 38.75 degrees multiplied by the impedance R1. Right? Impedance R1 was previously, we have recorded 15 at an angle of 0. So that gives me 33 at an angle of 38.75 volt. Similarly, the voltage across the inductor is I multiplied by ZL. Now, here should be 2.2 at an angle of 38.75 degree multiplied by the impedance. Impedance is 8, but this time we have a positive 90 degrees. That will give me about 17.6 at an angle of 90 plus 38.75. That's 128.75 degrees. Okay, that's the second answer for this question. And finally, what's the voltage across the capacitor? It's the current multiplied by the impedance across there. Okay, so again, 2.2 at an angle of 38.75 degree multiplied by impedance of 16 at an angle of minus 90 degrees. Okay, so that will give me 35.2 angle of minus 51.25. Okay, here we are, the 3 voltages required.